In today's tutorial, I am going to show you how you can install, set up, and run BUSCO on a Linux system. BUSCO is a tool that is used to assess the quality of genomic data. So genomic data here refers to genome assemblies, transcriptome data, and gen sets. Okay, so check this page out to read more about BUSCO. Okay, so make sure you do that. In addition, I also like you to check this page out. This is the user guide page. And also check this paper here. This paper here has tutorials that can help you get started with using BUSCO. Now, and let me also say that the ebook as well as the script for this tutorial are all available on my Patreon channel. So check the description box for the link and then you can use that to get the materials. So take note of that. Now, for this tutorial, if you want to follow, you need to make sure you have a Linux system. That is number one. And you should also have mamba or micromamba installed. Okay, so we are going to use micromamba or mamba to install BUSCO. I have tutorials that show how to install and set up mamba and then micromamba. So choose the one that you want and then use that to help you set up your system. So once we are done with the installation, then we are going to download an example data and then run BUSCO on those data sets. So that's what we are going to do. So let's get started. We will now move to the terminal and then install BUSCO. Okay, so we are on the terminal. So on the terminal, I assume that you have installed mamba or micromamba, but I'll use mamba, by the way. So we will need to first create an environment and install BUSCO in it. So I'll say mamba create-n and then I'll say BUSCO. So this is the name of the environment. Now let's also install BUSCO. So I'll say BUSCO. So this is it. And then we are going to add channels. So I'll say -c bioconda -c _forge and then -c defaults. I'm going to add these 3 channels. So once we do this, we can execute. So let's execute this command to install BUSCO. Now let's type Y to confirm. So once we do that, Mamba will download all the necessary packages, install, and configure them for us. So let's wait for everything to get done. Okay, BUSCO has been installed. So what we are going to do next is to activate the environment. So we will use this command to activate the environments and then run BUSCO. So if you installed BUSCO using Mamba, then this is how you activate it. If you install using micromamba, then you have to add your micro to this command here. Alternatively, you can run BUSCO directly by indicating or specifying the environment using this approach. But I will use this approach, so take note of that. Now let's clear the screen and then continue. We are now going to activate the environment. So I'll say mamba activate BUSCO. So this will activate the environment for me. So once the environment is activated, I'll find the name on the left side here. So that's it. Okay. Okay, now what we are going to do is to look at how to use BUSCO. So let's go to the user guide page. Okay, so we are here. So let's take a look at running BUSCO. So let's click this one, running BUSCO. And this will send us to the section which will show us how to run BUSCO. So with BUSCO, we have mandatory arguments and we have other options. So mandatory arguments, you have to specify them, otherwise BUSCO will not work. So with the mandatory arguments, you have to specify sequence file. So we use -i. You have to specify lineage. You use -l. You have to specify output name. So this is the name of the directory that will be created and then used to store the output files. That's -o. And then -m is the mode. And we have other options. So other options, that one, it depends on you and then what you want to achieve. So with the sequence file, in this tutorial, we are going to use a genome assembly data. So we will specify that. I will show you where to download it. And then with the lineage, we will specify one. So with the lineage, there are possible ones you can specify. So they are referred to as lineage data sets. And so you can list them and then look at the one which is appropriate for you. An example is this one. This is a lineage data set, bacteria. And you can also specify where it is. If you have downloaded and stored them on your PC, you can specify using this approach. But for this tutorial, we are going to download everything and then use the lineage straight away without having to download and specify. Anyway, I'll show you how to do that later on. Also, with the lineage, if you are not sure, then you can use the auto lineage. So that one is here. Let me just show you before we proceed. So let's check lineage data sets. This one. So click it. It will send you to that section. Then let's scroll down a bit. We will find that here. Let's check. I think I can also check. I can also search here. I'll say auto. Let me use this one. Yeah, automated lineage selection. So I can click it and this will send me to this section. So if you are not sure of the lineage, then you can use the auto lineage. So if you specify auto lineage, then you don't need a -L flag to specify your lineage. So take note of that. For this tutorial, we will use a specific lineage. So take note of that. I'll make tutorials which show how to use the auto lineage as well. So that'll be another time. Now let's get back to the usage again. I just want to give an overview of the usage before we use some example data. And then the output name, that is the name of the directory that will be created and then used to store the outputs. And then we have -M to specify the mode. So with the mode, let's just check again. Let's go to this section. We have genome mode, we have protein mode, we have transcriptome mode. Let's just click genome mode, for example. It will show us how to do it. So with the genome mode, you have to use genome. So this is used in situations, for example, where you have genome assemblies. You can use genome mode. And we also have protein mode, and we also have transcriptome mode. For this tutorial, we are going to run BUSCO on a genome assembly, so we will use the genome mode. I will make tutorials that show how to use these other modes, so that will be for another time. So take note of that. Yeah, and it has even been stated here. So genome mode, accessing the genome assembly, that has been stated here. So that's fine. Okay, great. So that is the general overview of the BUSCO usage. Let's go back. Yeah, so in this tutorial, we are going to use the mandatory arguments. We will leave the other options. That will be another time. So that's it. Now, let's take a look at the example data we will use. We are going to evaluate the genome assembly of a Salmonella enterica isolate, which is this one here. So we will download the genome assembly, which is this one, and then run BUSCO on it. I will leave the link to this page in the description box. So when you are here, you can click to download it. But because I am working on a terminal, I will get a download link and then use that. So to get a download link, I need to right click and then go to copy link. So the link has been copied. I'll leave the download link also in the description box. So after getting the download link, you have to go to the terminal and then download. So I'll first create a directory. So I'll say make the genome assembly. And then I'll cd into it. So I'll say cd genome assembly. That has been done. So now I'm going to download the example data. So I'll use wget to do it. So I'll say wget, and then I'll specify the link. So I'll download this file now. Okay, the file has been downloaded. So let's do an ls. We are going to find the file here. This is it. Let's just do it here. The file name is also long, so we can shorten it. So for me, I'm going to rename it, by the way, before I process further. So I'll rename using this one here. This will be the new name. Okay, that's what I'll do. So what I'll do next is to first extract the contents, and then I'll do the rename. That will make things shorter for us. So I'll just say Unzip, and then I'll specify the name, which is this one here. And then I'll execute this command. So this will download the file for us. So let's do an ls, and we are going to find the file here. This is it. So now I'm going to rename it because this name is too long for me. So to rename, I'll say mv, and I'll specify the original name. And I'll also indicate the new name, which is this one here. And I'll say .fne. That's it. You can also use .fasta because it's a fasta file. It depends on what you want, by the way. So I can say .fasta, or I can say .fne. Okay, so this is it. This is the new name. Again, I repeat, you can change the extension and make it .fasta is also fine, but I'll keep it as it is. So I'll rename now. Perfect, that has been done. So let's do an ls, and we are going to find a file there. Perfect. Now it's time to evaluate the genome assembly. So I'm going to evaluate this genome assembly using BUSCO. To evaluate, we will need to specify the lineage. So let's go back to this page. This is a Salmonella enterica isolate. I repeat, this is a Salmonella enterica isolate. So we need to get the taxonomy. So on this page here, let's just click this one. I'll leave the link to this page also in the description box. Let's click it to send us to this page. I'll leave this link also in the description box. I mean, the link to this page, I'll leave it in the description box. So when we are here, let's just check. And then we are going to find the taxonomy here. So let's just take a look at all of them here. So we have bacteria, this is up to this. So ideally, we want to go for the lowest one. I mean, the one which is available. If you take a look at the list, which we'll look at very soon, you need to go for the lowest one. That becomes more specific ideally, but if you're not sure, you can still go for a higher one, a higher name here. We have bacteria, and then we can also move down to these other ones. But let's take a look at what we have. So in this one here, let me just enlarge it a bit. So when I checked earlier, I realized we have this in the BUSCO data sets. So that's what we are going to use. Let's list the databases again. So I'll say BUSCO -- list data sets. Let's do that. So we have everything here. So I can just, instead of going through all of these, I'll just do a grep. I'll rerun the command again. That's why we are using Linux. I'll use a grep -i, then I'll use the name. Let's just go back to this page. I'm going to use this name here. And then I'll paste it here, and then I'll execute the command. So -i here means bash should ignore cases. That's it. So I'll execute this command. Perfect. So we have that here. So this is what we are going to use as the lineage. So I just thought I'll bring this up before we continue. Let's do an ls again. So we have our file here. So now we are going to run BUSCO to evaluate this genome assembly. That's what we are going to do. So I have my inputs data here, and I also have the lineage here. So I'm set. The genome mode will specify it. So we will now call BUSCO. So we say BUSCO, I'll say -m, and then I'll say genome, that is the mode. I'll say -i, I'll specify this file. That's the genome assembly. And then I'll say -o, I'll specify an output directory. So I'll say cvm. I'm using the same name here. And then next time I'll say _ BUSCO. That'll be the output directory. And then for the lineage, that'll be -l. And then I'll say, I'll use this one. So I'll just do a copy and paste. I don't need to type. I'll just copy and paste it here. So that is the lineage. So that's it. Alternatively, you can create another variable and assign this to it and then use that here. So that's it. So this is how we are going to evaluate this genome assembly. So let's execute this command. Okay. BUSCO has started this way, so let's wait for everything to get done for us. Okay, BUSCO has completed its work. So once it's done, you'll find a summary report here. So let's take a look at the interpretation. Let's go back to the user guideline. Let's check the interpretation section. So here, just come to this side, interpreting the results. So click it, and then you'll be sent to that section. So I'll just look at this paragraph. The rest I'll encourage you to read. So it says the results are simplified into categories of complete and single copy, complete and duplicated, fragmented or missing BUSCOs. So let's check them out. So complete and single copy, complete and duplicated, all of these are complete BUSCOs. Okay, so they are all labeled as C, and then there's a breakdown. Let's take a look at that. So that is what we have here. So the C is for complete BUSCOs. That is what has been given here. And then there's a breakdown. That is where the S and D comes in. So the S is for complete and single copy. D is for complete and duplicated BUSCOs. Then we also have fragmented, which is F, and we also have missing BUSCOs. And then N, that is the total BUSCO group search. That is what is here. So ideally, we should have a higher percentage for complete BUSCOs. That lets us know that the genome assembly is good. Now, aside the result summary here, there are other outputs you can check. Let's just check them here. Let's clear the screen. Let's do an ls, and we are going to find this directory. This is what we specified when we run BUSCO. Let's just do that here. That's what we specified here. So this contains all the outputs, including the summary. I repeat, this contains all the outputs, including the summary that we just saw. So let's take a look at what is in this directory. So let's say ls, and then we specify that directory. And then in it, we are going to find our files there. So we have all these files and all these files here. You can also use your file manager. Let's just use our file manager to check this directory. So this is the output. So when you open it, you'll find the files. And then you can also explore them. So a detailed explanation of all these outputs will not be done in this video, but I'll make other tutorials and then I'll try to explain these things. So we have a short summary here. You can open it. This is the TXT file. We also have a JSON file, and we also have this one here. I'll open this one. And then here, we still have summaries here, but I would like us to check this full table here. So this has details of the results. So you can open it with a spreadsheet software. It's a CSV file that is tab separated. So you can open it with a spreadsheet software, any spreadsheet software. And that is what I have just done. Let me just open it again. So this is it. So here we have the hits. So if you take a look at the genome assemblies, it's made up of contigs. So for each contig, if there was a BUSCO hit, it will be indicated. We have complete BUSCO. It tells us the contig on which that it was identified. We also have the gen start and end, strand, etc. We also have a link here that you can use if you want to look the BUSCO hits up. So you can check for all of them. Just scroll down and then we see them here. So we have all of them here. So complete, missing. So if you want to go deeper, then you can check this input file. Maybe you may want to inspect and then get some more information. Then you can do that. For example, if let's say you are interested in certain genes, then when you come to this spreadsheet document, you can open it and then extract whatever you want. Or there's a description here. You also have some location and scores here. You also have length. So, I mean, you can do extra analysis here depending on what you want at the end of the day. And so I thought I'll also bring this to your attention so that those who want to go further can inspect this file. Anyway, so that is it for the BUSCO output. Okay, so I am back. Now, what we did was to evaluate the genome assembly for a single sample. But you can also have multiple samples. Maybe you can have like 4, 5, 6, etc. And so in that situation, trying to view the report summary for each of them can be cumbersome, especially if you want to compare. And so it is possible to visualize the BUSCO results. BUSCO allows you to run a Python script to generate a plot, which is very useful if you have lots of samples. Okay, so you can generate a plot like what I'm showing, and I've covered a tutorial that shows how to do that. So just check the description box and you'll find the link to that video. I'll also leave it at the end of this video. Also, if you're dealing with multiple samples, then you need to write a bash script to automate the process. And so if you have lots of samples, maybe 10, 20, 30, 50, or maybe hundreds, then you can write a bash script. If you have a challenge tool, you can always contact me, book a session, and we can go through all this together and then get your analysis done. So just make sure to do that. And so that's where I bring a tutorial to an end. Now I encourage you to check this other video, which shows you how to visualize the BUSCO results.